This is a quick look at Nengi's prediction code. This has been released as a sort of quick little demo. It's not the final API, but it is functional. And this video is just a quick overview of what you can find in this video, what you can find in the demo and how to use prediction code. The demo contains something that looks like the Nengi tile demo, but the character's been replaced with this red circle. That's for the sake of it being easy to see what's occurring. The code has some differences. There is, inside of game clients, some new prediction code. You can take a look there, but essentially it finds out the ID of which character is ours. It's similar to logic before, but it does something new. It creates a version of the server-side entity using the exact same code from the server for the map, the entity, and the collision system. And it employs these to, on the client, basically run the same code that would be run on the server. In this demo, there's a few prediction modes. You can switch between them by hitting spacebar, but they demonstrate predictions occurring in varying states. The first prediction mode is no prediction whatsoever. It's the client moving around the game, or the client's entity moving around in just raw data from the server. No interpolation, no prediction. The following mode shows basic prediction, but doesn't account for the collisions. The mode after that is the perfect mode, really. It's the prediction of the entity and the prediction of its collisions. And then the final mode is just sort of a control group test where we have just the client purely moving the entity around on its own, unaware of anything from the server. What they look like is this. Let me refresh this, reset it to the first collision mode. So here we have raw data from the server. It might look a little shuttery. It's hard for me to tell because I'm recording at 30 frames per second, but the browser's going some totally different speed. We'll see what it looks like, but what I'm seeing on my end is that it looks like a game with kind of a low frame rate. That's because we're getting the data from the server at 20 frames per second, and that's all we're using to move ourselves with. The other thing about this is I'm going to insert some injected lag. I'm going to add, well, it says 125 milliseconds of lag here, but the way this program works and the way Windows works, when you're doing stuff on localhost, it's actually doubling it. So when I hit start here, it's going to add 250 milliseconds of lag, a quarter-second lag. In this scenario, I'm going to hit the keys loudly. Hopefully you can hear it. What I'm getting is a big delay between the keystroke and any movement. This is something solved by prediction, not only the fast, smooth, snappy movement, but lag. Lag is hugely concealed by prediction. So I'm going to go ahead and hit spacebar, switch the prediction mode to mode number 1. This is basic predictions without the tile map being considered. We'll see that even with some simulated lag, there is no lag. I hit the key and it moves instantaneously. I don't know how fast instantaneous really is. I would say it's occurring in less than 10 milliseconds. Then again, this monitor that's playing the game at the moment is 144 hertz, so that's possible. At 60 hertz, which is a much more common rate, you'd be 16 milliseconds delay, instantaneous in most people's eyes. So this is the one that doesn't have map collisions, so I'm going to go run into something, and we'll see we have a problem. The predictor does not know that there's a wall here. We start to move through it, we get snapped back, we rubber band. We rubber band proportionally to how laggy we are. 250 milliseconds is pretty laggy, so we can make it pretty far into the wall. If we turn down this lag or turn it off, we'll only have, I don't know how much lag we'll have with it off, just like a frame. So we get this sort of stuttery thing. I'm going to leave the lag back on because it's really about hiding lag and still keeping the game feeling good. So lag back on. The next mode is the same prediction logic, but this time it uses the collision system, it uses the tile map, and so the predictions should line up very closely with what we would expect from the server. I've switched to it now. We see I just run into the wall, and the wall is rigid. Also, for the sake of this demo, I'm essentially speed hacking my own game. I'm sending inputs very rapidly to the server just to show what it would be like with a really high tick rate. The server actually is running at 20 frames per second, not a high rate, but the client is sending them at whatever its frames are. In this case, well, it's bouncing around, but it's sending things at about 120 to 130 frames. So it's like a speed hack, but I left it on here for the sake of showing that it can be predicted, it can be insanely fast, very performant, very snappy, feels like a single player game even with the lag injected through it. Some of the other modes, not so interesting because it's not what you would use, this is the one you would use, are, let's see, what is the next one actually? The next mode is decoupling the prediction, the movement on the client from the server. That looks like this. They are totally unrelated now. You can just move anywhere you want. Mind you, I'm not really moving through this wall. It's just being drawn as if I am. The second I switch to one of the modes that knows where I really am, I'll snap back to wherever it is I got stuck, which is probably on that wall. This is just a good control test. You can see what is it like if the movement was purely done via the client. Is the prediction altering things? Is it adding any lag? The answer, I would say, from what I see here, is no. I'm going to switch modes. See, I've snapped to wherever it was I really was because I was totally desynced during that mode. Now I'm back to the laggy, no interpolation. No prediction, no interpolation state. So to use this, you'll just have to pick apart the demo code. Really, it's the first introduction of this code. It's for advanced users, but you can see the gist of it. You know, between importing code directly from the server, creating a single entity, which is the actual server-side entity, the exact entity, and then moving it around and passing commands to it, so that we end up with essentially the same path through a command being processed as we did on the server. We end up with that on the client, and then we move our clients, the art, the graphics. We move our graphical client's position to where this predicted thing ended up, and that's prediction done. It's also hard-coded at the moment to assume a delta between frames of 1/60th. This might work. You might need something else. The server does the exact same thing. The server on each command assumes that the command is to be applied with this delta of 1/60th. As you can see, this demo doesn't even use that. You know, the client here wasn't even running 60 frames per second. You can pick something else. You can also pick something more variable. I hope this gets people started with entity prediction and offers something for which I can receive some feedback for finalizing the API and making it a little easier to use. You can see the API here basically consists of client get unconfirmed commands. Contains a list of things that have been sent to the server but have not yet been processed by the server, and that's the set of commands used to form the prediction. Good luck, and you can email me if you have any questions. Thanks.